right, guys, we're going to talk about histograms, which are very similar to dot plots, only we're dealing with ranges of data. And they've been very nice to us. The data here, the situation is we have tomato plants, and this data represents the number of days it takes for different tomato plants to produce tomatoes. But they were very nice to us, and they put the data in order, which makes our job a lot easier. So we're going to fill out this frequency table over here and decide how many pieces of data go in each range. All right, so from 40 to 50, looks like we just have the one piece of data, so 1. From 50 to 60, we have 1, 2, 3, 4 pieces of data. The number 60 will actually go in the next set of data. So it's really like this is 50 to 59, 60 to 69, if that makes sense. All right, 60 to 70, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. From 70 to 80, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, from 80 to 90, 1, 2, 3, 4, 5, 6. And then from 90 to 100, we just have the one piece of data. So we can come over here and put this on our grid. From 40 to 50 is 1. From 50 to 60, we go all the way up to 4. All right, so you see how I'm doing that? 1, this one's the height of 1. From 50 to 60 is the height of 4. No, it's not exact. I'm just trying to estimate because we don't have an actual grid here. From 60 to 70, should go all the way up to 9. Let's be up here. You guys are probably better artists than me. You can make it look nicer. And then we have 9 again from 70 to 80, right? We had that twice, here and here and here. And then the next range from 80 to 90, we had 6 pieces of data. So I got to make that one go to 6. Then from 90 to 100, we're back down to 1. So that's what a histogram looks like. And we can get a lot of information from that histogram. We're going to talk more about that later. But we can change our ranges of data. And it changes the graph a little bit, the histogram a little bit. For example, what if we, instead of making it intervals of 10, what if we made it intervals of 5? So let's do our second histogram with intervals of 5. Okay? So from 40 to 45, we really don't have any pieces of data. From 45 to 50, we have 1. From 50 to 55, we have 2. From 55 to 60, 1, 2. 60 to 65, 1, 2, 3, 4. 65 to 70, 1, 2, 3, 4, 5. 70 to 75, 1, 2, 3. 75 to 80, 1, 2, 3, 4, 5, 6. 80 to 85, 1, 2, 3. 85 to 90, 1, 2, 3. 90 to 95, we have 1, and then we don't have anything from 95 to 100. So we graph it the same way. If I go over here to from 45 to 50, here I have 1 piece of data. 50 to 55, I had 2. 55 to 60, also 2. 60 to 65, I go all the way up to 4. 70 to 75, I'm back to 3. Or 65 to 70, rather. I have 5, excuse me. So I have to go up here. Almost skipped one. 70 to 75, I'm back down to 3. Ignore my little mistake there. 75 to 80, I have 6. So I'm back up here. 80 to 85, back down to 3. 85 to 90, also 3. And then from 90 to 95, I'm back down to 1. So you see how the graph looks a little bit different. The histogram looks a little bit different. And we can see information that we might not be able to see otherwise. For example, this drop here from 70 to 75 goes down to 3 that might be significant if we're growing tomatoes. So there might be an advantage in doing that. But just wanted to show you that you can change your interval if you want.